Paris has the Eiffel Tower and Sydney the Opera House. Now Saudi Arabia wants Riyadh, its capital city, to have its own unique icon, the Mukaab. At 400-meter dimensions in all directions, this giant cube can fit 20 Empire State Buildings inside. It will be the centerpiece of New Murabba, a gigantic development in Riyadh's downtown slated for completion by 2030. In time to host the 2030 World Expo, which is a ridiculously short timeline for a project of this size. Marketed as a gateway to another world, it has a holographic dome that transports its visitors to the wildest places imaginable. But can it ever come to life outside of a 3D render? Saudi Arabia got really wealthy thanks to its massive oil reserves, but with the world moving away from oil, it is pouring billions into construction to pivot its economy and to improve its international reputation as a major center of trade and tourism. Saudi Arabia wants to replicate what cities like Dubai in UAE and Doha in Qatar did, but on a scale even they could not dream of. It's why they've announced 15 mega projects recently, including the Line, Trojena, and the Oxagon. New Murabba will be situated at the intersection of King Salman and King Khalid roads to the northwest of Riyadh. Over an area of 19 square kilometers. It will provide residents in each neighborhood with access to housing, employment, all within a 15-minute walking radius. These accessible living spaces will then be connected via public transportation to 100,000 residential units and 9,000 hotel rooms and special community facilities. It will have more than 80 entertainment venues, several walking trails, large museum, and at the center of it all, Mukaab. According to Mukaab's designers, the cube-shaped design is the most efficient shape for accommodating all the technologies for the overall experience. The world's first immersive destination would be created by the latest digital and virtual holographic technology. But there's a problem. Holograms like the ones described in Mukaab's announcement don't really exist yet, so it's hard to see how they would pull that off. To achieve the immersiveness, Mukaab will also make use of giant LED screens inside the dome, just like Las Vegas Sphere. But there's a huge difference. Mukaab's screen would be 20 times larger than the screen used in Las Vegas Sphere, which is already huge. To understand how big, let's do a back-of-the-envelope calculation. Assuming the dome containing the screen is 350 meters tall, then its area can be calculated assuming a cylinder of 175 by 175 dimensions and a hemisphere on top with 175 meter radius. The internal surface area comes to 385,000 meters square. Now let's use an industrial modular LED screen with 10mm pixel pitch. 10mm pitch is enough in this case because the viewing distance is so far that it wouldn't be obvious to the viewer at all. It's also important to note that pixel density would still be 10,000 pixels per meter square. Now, one module consumes power of 215 watts per meter square on average, meaning the screen would use 82.75 megawatts of power and approximately 2 gigawatt hours of daily energy usage. To put that in perspective, that is equivalent to 68,660 US households. At this point, they should build the Mukaab its own power plant as well. But that's not all. The Mukaab will provide a footprint of 2 million square meters. Imagine the Empire State Building, but instead of a tower, it's a cube that's as wide as it is tall. And with the tower in the center that will rival the height of traditional skyscrapers. The exterior facade of the building will serve as a shell for the dome, which in turn will be a shell for the spiral tower. The spiral tower acts as a core and is home to tourist and cultural destinations, as well as a technology and design university and a multi-purpose immersive theater. It is 400 meters high, less than half the height of Burj Khalifa in Dubai, which means it's definitely doable. To make it structurally sound between the dome and the shell, there will also be a robust array of joists and beams to hold up the gardens on top of the cube. The skyscraper-like towers at each corner of the cube will help with the support as well. If that's enough to support the largest roof in the world, and the gardens on top remains to be seen. And let's not forget about the giant lake on top. Thousands of liters of water would significantly increase the structural stress. So the cube would have to be built extremely strong and would need to be waterproof, otherwise any accident could cause a lot of damage to the expensive technology underneath. These constraints can possibly lead to the project never even leaving the drawing board or needing massive changes. But let's dive deep into the details of the facade. The modern Najdi architectural style is used for the facade, paying homage to the rich cultural history of Saudi Arabia. The aim is to convey the traditional look of Arab residential buildings by mimicking elements of historic riverside Saudi villages with compact clusters of dwellings separated by narrow roads protecting people from the glaring sun's heat. While it's easy to criticize this design, the facade does have some benefits, keeping in mind Saudi Arabia's climate, as it will help to conserve and recycle water, save on cooling costs, and keep out sandstorms. As the weather is hot and dry outside, the facade will also provide protection to residents. Thermal insulation of an exterior wall is much higher than any transparent window, meaning much cooler days and much warmer nights than compared with if the facade had windows or was fully made of glass. But that is also a big downside. A big problem with buildings like this is getting light into the center of them and creating spaces that human beings actually want to inhabit, which they've tried to do with the big screen. That said, the screen cannot replace windows which let in natural light. Artificial lighting also does not get around the psychological issues that come with windowless environments. The positive effects of natural sunlight and windows is incredibly well researched. Humans need natural sunlight and exterior windows. The skyscraper inside the cube would have no natural light. The moment the power goes out, the whole cube would be rendered useless. There's also another issue. Building at great height requires a massive amount more material than a typical high-rise. The upper stories of super and mega tall buildings, which often include hundreds of meters of unoccupiable vanity height, are buffeted by ferocious wind loads, with any sway at all introducing enormous destabilizing forces into the structure below. They are home to hefty services that raise water, coolant, air, and people to these great heights. And they also must be offset by deep underground foundations. Even in areas with firm grounds, the awe-inspiring physics of skyscrapers has a huge cost. One research shows that the efficiency of structural material usage by floor area drops just above 3 stories. And according to another study, the whole life emissions of both energy use and materials for a 120-meter concrete and steel structure are nearly 5 times higher than that of a 60-meter high structure. Now imagine how much larger this number would be at 400 meters. The carbon cost of taller buildings is greater than carbon savings from restricted land use. This means that high-density, low-rise cities like Paris are more carbon efficient than high-density, high-rise cities like New York. On top of that, financial experts are already skeptical if the project could ever be funded. By 2030, Saudi Arabia is hoping to bring in more than $100 billion per year, which would help to finance this project, attracting new small businesses to base themselves around the construction projects, which propels the economy. But with uncertainty and tensions rising in the region, it could all still fall apart. But even if Saudi Arabia does raise the money, there are a lot of technical challenges that still remain. It's difficult to know if the project would ever be built. Perhaps it will be built as per the announcement, or maybe in a downsized manner. Even at 50 meters, it would be the largest cube in the world.